Okay, for section 7.2, we're going to start looking into right triangle trigonometry. And if you were to Google the definition, what is trigonometry, you would get some kind of generic general definition like this. Trigonometry is the branch of mathematics concerned with how angles relate to sides of triangles. Now, that's not verbatim, but that's some kind of general definition that you would get when you're when you're looking up a definition of trigonometry. Now, this is very basic. There's so much more to trigonometry, but at the kind of beginning, heart and soul, we're dealing with angles and ratios of sides of triangles. Okay, and that's what we're going to focus on in this first video for this worksheet is this right triangle trigonometry. And part of this is defining the six basic trigonometric functions. So the six basic trigonometric functions are sine, cosine, tangent, cosecant, secant, and cotangent. Okay? You do need to remember that. We're going to talk a lot about this. Okay? Now, as far as how we would start this, we basically define these six basic trigonometric functions based on how they have an angle that relates to ratios of sides. So we need to understand just a general right triangle. Now, a right triangle is one that has a 90-degree angle. So you can see here, we've drawn an angle, but we've thrown a triangle into it, okay? You can see we have our right angle right here, and then we have our angle theta right here. And we're telling you that theta is just some acute angle. So that means it measures less than 90 degrees. Now we've labeled the sides of this triangle A, B, and C. So sides A and B are what are called the legs of the triangle. They make up that right angle. The side C, notice it's opposite the 90-degree angle. That is always going to be called your hypotenuse. But more importantly, let's dive in a little bit deeper with A and B. Compared to theta, side A is adjacent to theta. That means it's touching theta, okay? Side B is opposite of theta, okay? So it's across from theta, all right? We have to remember that. So the side that touches theta that's not the hypotenuse is the adjacent side. The side that is not touching theta is the opposite side. And that is very important when we go to define these relationships, okay? So keep all of that in mind. Let me get my mouse. All right, so scrolling down, let's go ahead and define these six basic trigonometric functions. Now, I was playing around with my screen where I write on these notes, and something weird is happening in this table, so things are going to bounce around. This happened in another video in a different worksheet, so just be prepared. It's going to be weird for a second, okay? So the six basic trigonometric functions are defined as follows. So we have, remember, sine, cosine, tangent, cosecant, secant, and cotangent. So let's look at sine. First, we have an abbreviation. We abbreviate sine as just sin, and then in parentheses, we put our angle theta. So we're looking to see what sine of this angle theta is, and it's going to be a relationship or a ratio of sides of that triangle, okay? And it just so happens that sine is opposite over hypotenuse. And again, I don't know why this is bouncing around like this, so it's a little bit messy, but you can fill it in nicely, okay? Now, when we're dealing with cosine, we abbreviate it just COS, and then in parentheses our argument theta. And so we're saying when we find cosine of this angle, we're going to get out a ratio of sides. And the ratio of sides is going to be adjacent over the hypotenuse. Okay, again, I'm very sorry it's messy. I don't know what I've done with this table that makes it right this way. Okay, now tangent, we just abbreviate that tan. So we have tan argument theta. So that means when we find the tangent of this angle, we're looking for a ratio of sides. And the ratio of sides is opposite over adjacent. Okay, so again, messy, but you get what I'm getting at. Now we have cosecant. Cosecant is abbreviated CSC, again, argument theta. So when we find cosecant of this angle, what is the resulting relationship or ratio of sides? Well, the ratio we're interested in here is hypotenuse over opposite. All right. When we go to secant, we abbreviate it SEC, and then in parentheses, the argument theta. The result is going to be a ratio, and the ratio that we get when we're looking at secant of theta is going to be hypotenuse over adjacent. And then finally, we have cotangent. So we have cotangent of theta. We abbreviate that just COT. And that ratio of sides is going to be adjacent over opposite. Now, you're going to hear a lot of times, you just need to memorize this. You need to memorize this. And I hate telling students they need to memorize things because it can be kind of like stressful just knowing you have to memorize something. This is something you need to memorize. You have to know each of the trigonometric functions and how it relates to the ratio of the sides of the right triangle. Okay? Now, let's shorten this even more. So let me kind of shrink my screen a little bit so we can see a couple of things. Okay. Well, I don't really want it that small. There we go. Okay, so up at the top we had this triangle. Remember, the adjacent side is A, the opposite side is B, and the hypotenuse is C. So the next thing we want to do is it says use the triangle above to find the ratio of the six trigonometric functions. And in this case, we want to use A, B, and C. So we already know that the relationship of sine of theta is going to be opposite over hypotenuse. Well, the opposite side we called B, and the hypotenuse we called C. So the ratio of sides would be B over C. So you might see it written opposite over hypotenuse. You might see it written as B over C. Just make note of what triangle you're looking at and where angle theta is compared to the ratio of sides. Now for cosine, we want adjacent over hypotenuse. So that would be A over C. For tangent, we want opposite over adjacent. And then for cosecant, we want hypotenuse over opposite. For secant, we want hypotenuse over adjacent. And for cotangent, we want adjacent over opposite. Now, before we move further, I need you to notice something. So look right here and then look right here. What do you notice about cosecant compared to sine, secant compared to cosine, and cotangent compared to tangent? Hopefully you notice that these are reciprocals of sine, cosine, and tangent. And you can see it down here when we're using A, B, and C even better. Notice the reciprocal of B over C would be C over B. So sine and cosecant are reciprocals of each other. Cosine is A over C, secant is C over A over C is the reciprocal of C over A, and vice versa. So cosecant and secant are reciprocals of each other. And the same thing is true for tangent and cotangent. So this idea of reciprocals is going to come back up in just a bit. Okay? Now, it's really hard sometimes to memorize things. So if we can find little ways to make things easier, that's always helpful. So try to remember SOHCAHTOA, and then if you can remember SOHCAHTOA and reciprocals, you'll be good to go. So what does SOHCAHTOA mean? SOHCAHTOA stands for sine is opposite over hypotenuse. So S for sine, O for opposite, H for hypotenuse. Ca, CAH is cosine is adjacent over hypotenuse, and then TOA is tangent is opposite over adjacent. So if you can remember SOHCAHTOA, and then you can remember that sine has a reciprocal function, which is cosecant, cosine and secant have reciprocal ratios, and tangent and cotangent have reciprocal ratios, you can remember the six basic trigonometric functions. So remember SOHCAHTOA, okay? All right, and I think that's, well, let's do one example here. Okay, so let me make this a bit bigger again so we can see it easier. There we go. So example one says, consider a right triangle with an angle theta such that the adjacent side is 12 and the opposite side is 5. So part A here says, draw the triangle described and use the Pythagorean theorem to find the length of the missing side. If you're not familiar with the Pythagorean theorem, please become familiar. It's going to be a huge part of this. So we need to draw a right triangle. Okay. We're going to put our right angle in right here. We need to put in theta, so we're going to say theta is right here. We are told that the adjacent side is 12 compared to theta. The opposite side compared to theta is 5. And now we have to use the Pythagorean theorem to figure out the length of the hypotenuse. So hopefully you remember that the Pythagorean theorem is a squared plus b squared is c squared, okay? So A, we'll call it the adjacent side, that is 12 squared. B, we'll call it the opposite side, that is 5 squared. And if we can work this out, we can figure out what c squared is. So let's see, 12 squared is 144. 5 squared is 25. 144 plus 25 is 169. So we get c squared is 169. If we take the square root of both sides, we will get that c is equal, technically c is equal to plus or minus 13, but since we're talking about the length of a triangle, in this case, we're going to say c is positive 13. So this is 13 right here. Okay, now part B says find the exact value of each of the 6 trigonometric functions. What do you notice? Okay, well, we want sine of theta. Remember, sine of theta is opposite over hypotenuse, so 5 over 13. Cosine of theta, remember that is adjacent over hypotenuse, so that is going to be 12 over 13, okay? Tangent of theta is always opposite over adjacent, so that's going to be opposite side, which is 5, over adjacent side, which is 12. And then because we already know that these are all going to have a function that has a reciprocal ratio of sides, we don't really have to do any work. So remember, cosecant of theta has a reciprocal relationship to the sides of the triangle. So that would just be 13 over 5. We don't even have to do any work. Cosine has a reciprocal relationship with secant. So that would be 13 over 12. And then finally, tangent and cotangent are related in the sense that they have a reciprocal relationship with their ratio of sides. So we would say that cotangent is 12 over 5. So as long as you have two sides of a triangle and you know it's a right triangle and you know what theta is, or you know which angle you want to call theta, you can find all 6 of the trigonometric functions. Okay?